Today we practiced finding volume of pyramids and cones, and we learned that it's not that different than finding volume of prisms and cylinders. There's just a factor of 1/3 because the volume of a cone or a pyramid is 1/3 the volume of a prism or cylinder with that same base shape. So let's take this grain silo and recognize that it's made up of two pieces. The first piece would be this cylinder, this large cylinder, 50 feet tall, with a diameter of 15 feet. And secondly, at the top of the silo, you have this cone. Let's call this piece 2. And to find the volume of the entire grain silo, we could just do the volume of the silo equals V1 plus V2, the volume of the cylinder plus the volume of the cone. If we write down formulas for V1 and V2, the volume of the cylinder is just area of the base, that circular base, multiplied by the height of the cylinder, which is clearly 50 feet. The volume of the cone, piece 2, is also area of the base multiplied by the height, but just 1/3 of that, 1/3 the area of the base multiplied by the height. Of course, it has a different height. It's got a much shorter height of 8 feet, but it has the same circular base. So really, if we can find the area of this circle, most of the work is done. So I'll do that with you, and then I'll pause and have you finish this up. The area of this circular base, the area of any circle, is pi r squared. The area of this particular circle is approximately 3.14 multiplied by the radius, which we've not been given. This 15 feet, this line goes all the way across the circle, so that's the diameter. The radius would be 15 divided by 2, which is 7.5 feet. So our radius is 7.5, and we need to square that. 7.5 squared is 49 and 25/100ths. No, it's not. Excuse me. That would be way too easy. 56 and 25/100ths. Multiplied by 3.14. And as long as you write your formula and substitute your values, it's okay to use a calculator on this. So 3.14 multiplied by 56.25 is approximately 176 and 625 thousandths. Now, to make life easy on yourself, this is already an estimate, so let's just round. As big as this number is, let's just round to the nearest whole, 177. 177 square feet is the area of the circular base. Now, you substitute that into these formulas, and then substitute in the appropriate height for the cylinder and the cone, and then you should be able to finish this off. Try to do that during the pause, and then come back and see how you did.
Paused.
We're in a position now to just substitute the area of the base, which we've already calculated. Our estimate is 177. The height of section 1, the cylinder, is 50 feet. And 177 multiplied by 50 is 8,850 feet cubed. For volume of shape 2, the cone, it's 1/3 of 177 multiplied by the height of the cone. The perpendicular distance from the vertex to the circular base is 8 feet. Now there's something nice going on here with 177. I just noticed, I added the digits quickly, and 7 plus 7 plus 1 is 15. So I know 177 is divisible by 3, so I'm going to take 1/3 of 177 right away. It's going to be 59, because 5 threes is 15 and 9 threes is 27. So this just works up to 59 multiplied by 8, which is also pretty easy. I don't need a calculator for this. 50/8 is 400. 9/8 is 72, so 472. I should say approximately equal though, because remember, this 177 was an estimate. I should have done the same thing over here. I wasn't thinking about that. These are all estimates. But the our overall estimate for the volume of the silo will be V1 plus V2. Well, this is exactly equal, but we're about to substitute estimates. So the volume of the silo is approximately 8,850 plus 472. That'd be 9,200 and another 122, so 9,322. 9,322 cubic feet. I'm just going to double check. Yeah, that works. You may have a slightly different answer depending on how you rounded. I may announce a slightly different answer in class when we grade this, but anything close to 9,300 is a good estimate for the volume of the silo. I hope that helped.